Hi everyone. In this video, we are discussing a SQL challenge on Hackerrank, and it's a basic join type of problem, and it's a medium level problem. So let's read the problem statement, and we have quite a lot of information to consider here. So let's read very carefully. Let's take it slowly. Julia just finished conducting a coding contest, and she needs your help assembling the leaderboard. So they have some story. Okay, so we will have to read the story. We can't help it, but eventually we'll focus on the actual database and the schema given, right? So there is some person by the name Julia who finished conducting coding challenge, and she needs your help in assembling the leaderboard. And we need to write a query. Okay, here comes the main detail. We need to write a query to print the hacker ID. Okay, that is one information we want. Hacker ID and the name of the hacker. Okay, that is the other information we want. And it is not just hacker ID and name of the hacker of all the hackers. It is only those hackers who achieved full scores for more than one challenge. Okay, so we have multiple constraints here. We need hacker ID. We need the name of the hacker. And also we need these two information only for those hackers who obtained full scores on more than one challenge, right? If there are hackers who didn't get full score at all in any challenge, we're not going to count them. Or if there are hackers who got full score but only in one challenge, even then we're not going to count them. So they must be getting full score in at least two challenges. Okay. Now, not just that, we will have to even order the output in descending order by the total number of challenges in which the hacker earned a full score. Okay, that makes sense. That's because we want to see the top performer. So we would like to rank them according to the number of problems in which they got full score in descending order, right? So in that way, we will have to order it. And if there is a tie, okay, so that is what they mean by saying that if more than one hacker received full scores in same number of challenges, for example, there is a hacker A and hacker B, and they both got full score in 10 problems each, right? In that case, we will have to sort them by the hacker ID in ascending order, right? So these are the constraints. This is the entire problem statement, right? And we will have to consider things one by one. We are not like, going to code the entire thing out in one go, right? We will take it step by step. Okay, we'll solve this entire problem in parts, right? Okay, so let's check the schema. So the input format is going to be like this. So there are, there are 4 tables given. We'll get to these examples later. So there are 4 tables given. Okay, the table 1, the first table is called as hackers. Okay, and what do we have in this table? We have only 2 information. We have hacker ID column, which is going to be an integer. And we have name, which is going to be the name of the hacker, which is going to be a string. Okay, so only these 2 information are there in this table. And we have another table given called as difficulty. And in this table, we have again only 2 columns. One column is the difficulty level of the challenges in the contest. And the other one is the score, right? Score is the score of the challenge. That is the maximum score. Okay, so for this particular challenge, with so-and-so difficulty, we are going to award this many marks. Okay, so that is a score of every single difficulty level. That is a maximum score. Now there is another table called as challenges. In this table, we have the following 3 information. One is challenge ID. The second one is hacker ID. The third one is difficulty level. Okay, only that hacker ID requires some explanation. Challenge ID is pretty straightforward. Okay, so that is like we need unique ID for each and every challenge created. Okay, hacker ID, it's clearly stated here. Hacker ID is the ID of the hacker who created the challenge. It's not the ID of the hacker who solved the challenge. That comes later. This is the ID, hacker ID of the hacker who created the challenge, right? And difficulty level is the difficulty level of the problem of the challenge. Okay, so that is obvious. So challenge ID, difficulty level, they both are straightforward. Hacker ID is the one who created it. Okay, so don't get confused. And then we have submissions table. Okay, here we have these details, these columns. So we have submission ID. Okay, that makes sense. Every single submission is, entered in that table, right, in the database. Okay, so for that we have an ID and hacker ID. So this time the hacker ID is the ID of the hacker who solved it, right? In the previous table, it's the ID of the person who created it. And here it's the ID of the person who solved it. Okay. And challenge ID is like every challenge, every problem will have a identification number, right? So it is that ID. And score is the score of this particular hacker only. It's not the maximum score. Maximum score can be found in the difficulty table. For this much of difficulty level, we are going to avoid this much score maximum. Okay, so this is the score of that particular individual who made that submission. Okay, so these are the 4 columns in the submissions table. So these are the 4 tables that we're going to deal with. This is the entire schema. And let's check some examples. I don't think that examples are going to be useful for us to understand the problem, because it is going to be a bunch of numbers. Okay, so it's at least for me, it's quite confusing to try to read these numbers and make sense of it. Okay, bunch of numbers we have. This is like, submissions table. You can see we have submission ID, hacker ID, challenge ID, so on. Okay, so it doesn't make any sense. Okay, the only table to contain some name is hacker table. Except for that, all other tables are just numbers. It's not really worth discussing these examples. Okay, we will have to check where that same number is appearing in the other table. Okay, so it's a lot of works. We cannot properly dry run this problem, is my point. Okay, so let's not even attempt to do it. Okay, so don't worry much about the examples. Let's focus on the schema. That should be enough to solve this problem, to get the idea at least. Okay, so what is the output? They very clearly stated we need the hacker ID and also we need the name of the hacker. Okay, so this is what we are going to select. Select hacker ID from where we are supposed to select. You see, of all these tables, the most important table is the submissions table, because this table is going to act like the the joining table, like the union table, because this table is referring to all other previous tables, right? So sorry, it's not referring to all of the previous tables. It's not referring to the difficulty table, but it's referring to other tables. I'll explain that difficulty table part later. Okay, in a while. Okay, so we have submission ID, that is the primary ID of the submissions table, and we have hacker ID. This is a foreign key which is referencing the hackers table, and we have challenge ID, that is another foreign key referencing the challenges table. And why we don't have difficulty level here? Because it's pretty obvious that would be redundant to have difficulty level here, because once we have challenge ID, we will know the difficulty level by referencing the challenges table. We will very easily know the difficulty level. So there is no point in mentioning that over here. Okay, so submissions is the main table to which we are going to join other tables, right? Okay, so we have to select submissions dot hacker ID, right? Submissions dot hacker ID. Okay, it's not case sensitive, but let's try to avoid confusion. Okay, so submissions dot hacker ID, right? And that is one thing we need to select. And also we need to select hacker name, right? Hackers dot name. Okay, so that will give us the hacker name, and we are selecting these from where? From submissions table. Of course, in the submissions table, you have only the hacker ID. We don't have name. We don't have anything called the name column in the submissions table. Okay, so that is when you know that you will have to join the other tables. Only then you will get complete picture, right? Okay, so submissions is like the main table to which we are joining. I'm using the default join, the inner join, because that makes sense. We wouldn't want to have any column empty, right? So we'll go with the basic default join, inner join, right? So we are joining what? First, let me join the hackers table so that we will instantly get that hacker's name. Okay, so first let me join hackers table. On which parameter, on which column we are joining? We are joining on the hacker ID only, right? So we have hacker ID in the submissions table. We also have hacker ID in the hackers table. So we will have to naturally join on that particular column, right? That makes sense. Okay, so we are joining on hacker ID. So submissions dot hacker ID should be equal to hackers dot hacker ID. Okay, so there we are joining the hackers table to the submissions table, and we are also joining now challenges table, because that is common sense, right? Who is the hacker and which problem did he solve? So we need both the information. Okay, so the hacker details we want, and we also want the details of the problem that he is solving or he has solved, right? Okay, so challenges table, we will join challenges, and on which column we are joining? Again, it's pretty obvious, challenge underscore ID. Challenge ID is the foreign key referencing this challenges table. Here also you have the same column name, right? So submissions dot challenge ID should be equal to challenges, right? Yeah, dot challenge ID. Okay, so are we done joining only these two tables? Definitely no, because we need to join one more table, that is the difficulty table. Why it matters? I'll tell you why it matters. I'm joining difficulty table. On which parameter we are joining difficulty table? We are joining it on the difficulty level. You see the challenges table, you look at it like I'm joining difficulty table to the challenges table. Okay, so challenges table has got difficulty level as one of the columns, and the difficulty table of course also has one of the columns as difficulty level. We are joining it on that column. It'll make sense once we proceed further, right? So difficulty dot difficulty level. Okay, so on this column we are joining, the same column is present in challenges table. Challenges dot difficulty level. What is even the purpose of difficulty table? It serves only one purpose: for which level how much maximum marks we are awarding. That's it. That is the whole point of difficulty table. The difficulty table is not going to contain any other detail such as the challenge ID or the hacker ID, hacker name, nothing else. It serves as a quick lookup table to know how much maximum marks we can award for any given challenge solved by a given hacker, right? Nothing more, right? Okay, so that is the difficulty table. Even that has been joined. Okay, so we have now 4 tables combined. Okay, so now here is where we have to start doing filtering process. Okay, so what is the condition here? We will have to query all those hackers, their ID as well as name. Okay, that is taken care of, who got full scores for more than one challenge. Okay, that more than one challenge part will come to it later. So what do you mean by saying that they got full score? How do we know whether they got full score? The logic is simple. Go to the submissions table. Like I told you, out of all these tables, submission table is the most important one, because from there you can branch out to other tables, right? Now in the submissions table, we see a column called a score. First, let's understand what that score is. That score is the score given to the hacker who solved this particular problem, right? It's the score awarded to the hacker who solved that one particular problem. Okay, so submissions dot score. Okay, I will have to put that where clause. Submissions dot score is the score or the mark obtained by that particular hacker. And when can you say that that particular hacker, any particular hacker has got full marks? That submissions dot score should be equal to the only table to contain the full score for any given challenge level, not any given challenge, but any given challenge level, because every challenge we are giving some suitable difficulty level, right? So the only table to contain the full score for any given challenge level is the difficulty table. So the score that you see in the submissions table should be equal to the score that we see in the difficulty table. That means that the hacker has got full score on that particular challenge, right? Okay, so we should equate it to what? Difficulty dot score. So this is the filtering criteria. Okay, so this is how we are performing the filtering. Okay, now are we done? There are other things we need to do. We will have to order our output by the descending order of the total number of challenge solved. Okay, and even before that, we will have to do something else. Okay, so what do you think will happen if we just simply run this code? Any guess? You can pause and guess. What will happen if we just run this code? Ordering is not the only thing that is pending here. There is another very important thing we need to do. Apart from ordering, there is another very important thing we need to do. The issue here is, if a hacker, like say Hacker A, it's not necessary that he's going to get full marks and full score in only one challenge. In fact, we don't even want to output such people. Okay, we want to output only those people who got full score in more than one challenge. So definitely wherever they are obtaining full score, in all those rows, we are going to keep this code will keep printing the hacker ID and the name. So we will get multiple entries in the output. Okay, you will get the same name repeating multiple times in the output. So I'm just running the code to show you that, and we can easily fix it. Okay, you know the fix. It's taking longer than usual. So yeah, here we got it. Okay, so like I told you, this hacker with ID 10,857 name Kevin, his name is repeating this many times because he had clearly got full score in multiple problems, right? So Paul is repeating so many times. Okay, so on. James is repeating multiple times, so on. So how do we fix this? We are going to do group by, right? Let's do group by. Okay, we are going to group by what? We are going to group by submissions dot hacker ID. Okay, so it's enough to group by only the hacker ID. Okay, that is a unique identifier, but let's also put hacker name, because if I group by only hacker ID, then I will have to use some aggregate function. I can put max or something, it will definitely work, but I don't want to do it. Okay, just I'll simply type hacker dot name. It sounds like it's redundant, but we can't help it. Let's do it. Okay, so we are grouping it by the hacker ID and the hacker name. Okay, and after grouping, we have to do one more level of filtering. The first filtering is this where clause, where we are counting only those students who got full score, right? But if you read this carefully, it's not just those students who obtained full score. They should have obtained full score in more than one challenge, right? So how we are going to achieve that? Another filtering we have to do, and we have to be a little bit careful here, because you can't use another where clause here. As you all know very well that once we apply group by statement, we cannot use where clause. We will have to use instead having. It kind of does the same thing, but having will work on aggregates, whereas where will not work on aggregates. Okay, so that's the only small difference. Okay, so we are going to put this having clause. Having what? Having count. Count of what? Count of star greater than 1, right? So having a count of star greater than 1, so it is going to count only those students who got full score in more than one challenge. Okay, so that is what we are getting here in this having clause. And also we will have to do some order by. We will have to order by what? We will have to print our output in the descending order by the total number of challenges solved by the hacker, so which is count of star. Okay, so we will have to order by count of star, but descending order, because we want to see the top performers first. That makes sense. So it has to be descending order, and wherever there is a tie, we will have to order them based on the ascending order of the hacker ID. Okay, so ascending order of the hacker ID. So I'll simply put 1. That 1 refers to this hacker ID. right? I don't have to say ascending because by default it's ascending. So let's run this code, hoping that it won't have any errors. Let's see. Again, it's taking longer than usual. Okay, there is an error. What is the error here? Unknown column hacker dot. Okay, it's the table name is not hacker dot name, it is hackers. The table name is hackers. So where did I mention hacker dot name? Yeah, right here. Okay, right here. I don't even have to type it. Okay, like we could have simply done it like 1,2. That will do the job, right? 1,2 is more than enough. That 1 refers to the first column that is being selected, and the 2 refers to the second column that is being selected. Like whatever I told you over here in the order by, that 1 refers to this. Okay, so that will do the job. Let's run it again. So this time it should clear. Let's see. I don't know why it's taking so much time to run these queries. Okay, anyways, it's accepted. So the test case we cleared. Let's actually submit our code. I hope everything should be fine. It should be smooth. Great. Our solution has been accepted, and this is our query which meets all these requirements, right? So this is a pretty good problem. I hope that you found this video useful. Thank you for watching.